A lot of developers think that using AI means you stop engineering, but honestly, the opposite happened to me. Building the Untold Engine actually forced me to become more disciplined once I started using AI tools like Claude and Codex, and especially in rendering engineer, where one bad shader or one incorrect optimization can completely destroy performance. You cannot afford just blindly paste AI generated code into your engine. So in this video, I want to show you how I actually use AI while building the Untold Engine, the 3D renderer that I've been building for over 12 years now. Now, I know some developers don't like AI in their software development, and honestly, I understand why, because at first, I didn't like it either. I would ask AI to implement something, it would generate a bunch of code, and sometimes it looked correct, but it actually wasn't solving the real problem. So over time, I developed a workflow that actually works for rendering and engine development. And the first thing that I do is this. I gather as much data as possible before asking AI to do anything. For example, since I work heavily with Vision Pro, Metal, Swift, and Xcode, I spend a lot of time capturing GPU traces and performance data. I want to know how many milliseconds a render pass is taking, which shader is expensive, what percentage of frame time is spent in a compute pass, whether bandwidth or occupancy is becoming a bottleneck. I try to understand the problem first. And this is important. I don't sit in front of Claude and say, hey, implement this shader for me. I do not do that. Because if you don't understand the problem first, then AI is basically guessing. And that's dangerous in rendering engineering and in any engineering actually. So after gathering the data, I review it myself first and then I share the relevant information with Claude. Now let's say we determine that a particular compute shader is too slow and we need to implement a new sorting algorithm. And this is where my workflow becomes very different from what most people do. Before asking AI to implement the algorithm, I ask it to help me create unit tests first. This has probably been one of the most important changes in my workflow because now we have something to validate against. We know what the current output should be. So instead of blindly generating code, we create checkpoints. Then we start implementing the system in milestones. For example, maybe the sorting algorithm requires multiple kernels. So instead of implementing everything at once, we validate one kernel at a time. Pass the unit test, then move to the next kernel. Pass the next unit test, then we continue building from there. And honestly, this changes everything. Because now AI is not just generating random code, it's working with a system of validation. And that's extremely important for rendering engineering. Now, here's another thing that I think developers should not skip. You still need to understand the algorithm yourself. And I think this is where some developers make a mistake. They ask AI to implement something they do not understand at all. And that is a bad idea. You don't need to become a world expert in that topic, but you should absolutely spend time understanding what the algorithm does, what kind of output to expect, what the data flow looks like, and what are the limitations of the algorithm. Even spending 1 hour reading about the algorithm makes a huge difference because if you do not understand the expected behavior, you won't even know when AI is wrong. And trust me, AI can absolutely be wrong, especially in graphics programming. Then, after the implementation is complete, I use AI one more time. I ask it to help me document the system. Things like how the compute passes work, what assumptions the shader makes, what the architecture looks like, possible corner cases, why certain decisions were made. And this becomes very useful later because eventually bugs always show up. And when that happens, I already have the documentation, the GPU traces, the unit tests, and the architecture notes. So we can now diagnose the issue much faster. And honestly, I think this is where engineering is heading. I don't think the future engineer is just going to sit there typing code all day. I think the real value is becoming understanding the system, diagnosing the problem, validating the solution, and knowing what should exist in the first place. It's actually very similar to how doctors work. Doctors don't randomly guess treatment. They gather tests, they gather data, they diagnose the problem, and then they decide on a solution. That's very similar to how I use AI while building the Untold Engine. AI helps me move faster, but I still needed to understand the architecture, the rendering pipeline, and the problem itself. And honestly, if anything, AI has forced me to become a better engineer. because now I spend more time thinking about systems, debugging, architecture, and validation instead of just typing code nonstop. So that's currently my workflow for using AI tools like Claude and Codex while building the Untold Engine. And as always, guys, I'll see you guys next time.